So last time we discussed how electrons, when they jump energy levels, they emit a specific color. We're going to talk a little bit more detail what these quantum numbers actually mean. So for example, here we have in quantum n equals 1, or principal quantum number 1, or principal energy level number 1. All of these principal energy levels that you see here have sublevels. And the higher the energy level you go, okay, the more complicated it gets, the more sublevels you have. So for example, principal energy level number 1, okay, only has one sublevel. It only has one orbital, and that is the s orbital, okay? And that orbital, that one orbital can contain a maximum of 2 electrons. So you can say times 2 will equal 2 electrons for that orbital, okay? Principal quantum energy level number 2, as you can tell, it's a little bit bigger than 1, so it's a little bit more complicated. It has an s orbital, much like the first one, can contain a maximum of 2 electrons, okay? But it also contains a p orbital, okay? This p orbital has three orbitals, which can contain a maximum of 6 electrons. Then, as you can see, the third principal energy level has 3 sublevels, and this d sublevel contains a maximum of 5 orbitals. And then the fourth energy level has an additional f orbital, which has a maximum of 7 orbitals. Okay, so we're going to try to make sense of this by looking at the periodic table. So when you look at the periodic table, let's just break it down into basically into the sections that the periodic table can break down into. The first section is this part right here that I'm highlighting. This is where my s orbitals are contained. Okay? And then I come across the periodic table to this area, to my nonmetals and my gases. This is my p orbital, my p orbitals. Okay? And then in the middle, my transitional metals. My transitional metals are my d orbitals. Okay? And then last but not least, my lanthanines and actinines. These are my f orbitals. Okay? So you'll remember how we started off with the S. Principal quantum energy level number 1 has an s orbital. And if you recall, that principal quantum number also equals the period. Okay, so n equals 1 is found in period number 1. So n equals 1 is basically all the elements that are found in period number 1. And n equals 2 is principal energy level number 2, which takes up all the elements on period number 2. And if you remember, back to our previous page, principal energy level number 2 has an s orbital and a p orbital. So we can look here that energy level number 2 has a s orbital, and then once that orbital is full, it now jumps over to the p orbital, right? Okay, so let's take an example. Let's take the example of the first period. So n equals 1. Principal energy level number 1. That's hydrogen. So I can label hydrogen as principal energy level number 1, s orbital, electron 1. If I add another electron to this, now I'm talking about still same period, 1, s2. Then I jump down to the second level. This is principal energy level number 2. So this is 2s1, 2s2, and then I jump over still. Now I'm still on energy level number 2, so this is 2p1, 2p2, 2p3, 2p4, 2p5, and 2p6. So if I was looking to label oxygen, for example, I could label oxygen I could label oxygen as 2p, and it's 2p4. Okay? So then now I'm going over to energy level number 3. That's 3s1, 3s2, jumping over again, still on 3, 3p1, and that extends all the way to 3p6. Now I want to talk about principal energy level number 4 right here. Okay, because something interesting happens. It happens here in my d orbitals. Okay, there is an exception. Okay, there is an exception to the way my numbers break down, but it still is the same here in my S. So this is 4s1, 4s2. But then as I jump over to my D, which is in period number 4 technically, okay, so my P's, this is still 4, so I go from 3p to 4p1, 4p2, and then to 4p6 as normal. But what happens in between here, something happens in between here, in between our 4s and our 4p. This d orbital right here jumps up 1. So if this is 4, then that means this is now 3. 3d1, 3d2, and then all the way down to 3d10. And then this would be 5s1, 5s2, and then 4d1 all the way down to 4d10, and then I would continue on with my p's as 5p1 all the way to 5p6. Okay, so my d orbitals go up 1. Okay, they go up 1. Then my f orbitals go up, they go up 2. Okay, so if my lactonide series begins right here in this area, and this is 6s1, 6s2, and if my d orbitals go up by 2, and if this is 6, then this lactonide series would be 4 f1, 4 f2, all the way down to 4 f14. And then I would continue on. This is 5, so 6p1 all the way to 6p6. So again, my d orbitals go up 1, so 4 to 3, 5 to 4, and then I continue on with my p's. And then my s orbitals go s, 6s. And then when I jump to my f orbitals go up, they go up 2. So this is 4, and if this is 7s, then this actinide series would be, if it goes up 2, it would be 5f1 all the way down to 5f10. I would go 5, okay, 6d, and that would be it. Okay, so that is how, so you can kind of summarize what we're talking about here. So my s orbitals, again, are my alkali metals, alkali earth metals, and it only takes 2 electrons to fill it up. So this would be s1, s2, that orbital is full, so then I jump to my p orbitals. And my p orbitals, I need 6 electrons to fill those up. And then once I fill that one, I move on to the next energy level. Okay, so energy level number 4, n equals 4, my 4s orbitals, s1, s2, then the next energy level, okay, would be my 3d, and then continue on to my 4, and then jumping down to my n equals 6, s1, s2, my f's would be then 4 and 5, and my f would be just minus 1, goes up 1, 5, and then 6p. Okay, so this takes practice. You have to keep looking at this information, do the word problems in the textbook, And the more you practice this, the more you look at it, the more you familiarize yourself with it, the easier it will become. So it might be a little confusing at first, a little complicated. That's normal. So don't stress yourself out too much. This is a normal process of understanding this concept, but it's important that you keep practicing. Okay, practice the problems in the notebook, and this will get easier.